Okay. Um, so how do we, given a vector, right? How do we figure out its magnitude or how long it is, right? If a vector is, xi, yj, zk, to figure out its length or its magnitude, all we have to do is square every single term in it. But why? Before I move on to parallel vectors, why is that true? Well, it's a pretty simple theorem, and you guys have definitely come across it before. I'm gonna start doing it. Oh my god! Wow. All right. No clue what happened though. My hand just like jittered. Um, I'm gonna start with doing this in 2 dimensions, because once we start doing it in 3 dimensions, it gets a little bit more crazy. So we have x and we have y, right? If I make the vector OA, so OA, um, well, how would I go about finding the length? I'll give you guys a few seconds to think about that, and then I'll sort of spoil you. So, um, you know what? I'll let you guys. I'll make a poll for you guys to do. Um, create new poll. Word cloud. What theorem can I use to figure out magnitude? So my hint to you is that it's a theorem that you guys have come across in the past. Um, try look at this. It's 2 words. Try throw those up on there. I'll give you guys a couple seconds. Alrighty. Um, maybe a few seconds more. Okay, yeah, pretty sure. Everyone sort of has the same idea. It is Pythag. Um, alrighty. Um, okay, so simply all we do is get our x component, our y component, and we just want to find the magnitude, right? So we just square them, add them together, take the square root. Pretty straightforward. Another thing to note is that magnitude is always represented with these two like pipes. Um, you guys have probably maybe come across it if you've done modulus functions. But yeah, it just indicates length, size, positivity, that stuff. All right. Let's talk about parallel vectors. So two vectors, if they're parallel, facing like the same direction, um, they can be, they're if they are parallel, or if they look parallel, generally they follow this mathematical property. So this is what we use, this mathematical equation here. That's what we use to, say that a vector is parallel. So sometimes they'll ask you, prove that these two vectors are parallel. And to do that, all you have to do is you need to show that there exists some k um, that is a scalar that fits this, that fits the bill. So, maybe you have two vectors, AB and AC, um, or OA, OC, and you need to show that they're parallel. All you really need to do is you need to factorize out one of them till it looks like K times OA, if that makes sense. Like, if we're trying to do something to OC to prove that's true, what we can do is we can sort of like factorize this K factor out, and then sort of manipulate our vectors around till it fits this. But yeah, so the reason that's true is because, two parallel vectors don't have to be of the same length or the same direction. So they can be like this, right? But if let's say, I multiplied this by some negative, some negative number, maybe like -10, what's going to happen to it is it's going to flip around and it's going to get stretched out, right? Likewise with this, if I multiply by negative, 1/10, it's going to get flipped around and squished. So yeah, hopefully that makes sense. Alrighty. And then unit vectors. I talked a little bit about it when I was talking about the I, J, and K. Also, um, just something to point out that these I, J, and Ks don't have any sign showing that they're a vector. They don't have the arrows, the J's, I mean, they don't have the arrows, the tildes, or they're not really in bold, right? They're not like a different color from the X, Y, and Z. So if I wrote that in an exam, I would be losing marks. Um, but yeah, just thought I should point that out. Okay, so unit vectors, I was talking about them a bit before with the ij's and k's. They have a magnitude of 1, and they generally only specify direction. Um, they're really like, you know, yeah, they're just like saying like north or east or south, or they're just pointing in a certain way. But their magnitude is always going to be 1. Um, one cool thing we can do is we can sort of like get any magnitude. So let's say, we know like the speed of a car, and we don't really know much except that the next car next to it is traveling north. What we can do is we can get the unit vector of this other car that's traveling in the same direction north, and multiply it by this magnitude that we have for this other car, and we'll get the vector for the car that the new car, if that makes sense. Sorry, that was very wishy-washy. But yeah, so it's pretty nifty. That's what its main use is, so translating directions across onto other things. So all we have to do to figure it out is we get our full vector, and then we divide it by its magnitude. The reason this works is basically what we're doing is we're getting this whole length of this vector, and then we're dividing by its own length, so that shifts down to 1. But it still has its vector component, right? But since it still has its vector component, it still shows us a direction. Alrighty, hopefully that makes sense. Okay, I'll give you guys a little bit of time to have a crack at this, and then we'll come back. I'll probably give you guys, I'll give you guys a minute or so on this one here, maybe a little bit longer, 2 minutes. Um, in this case, it's really important to draw your scenario out, just because I feel like visualizing, this and this is a little bit hard. So I'd put the points P, Q, and R just randomly using these relative position vectors. And then I'd put in point S, and then I'd try to figure it out from there. Okay, hopefully that was enough time to go through this. So I'll try to create a solution for it and walk you guys through. So we have 3 position vectors, P, Q, and R. One thing you'll notice is they're not in terms of A and B, or they're not in terms of I, J, and K. A and B are their own vectors. We don't know what they are. They're just the relative vectors that we're dealing with here. So we can't treat them the same as I, J, and K. That's an important consideration to make. So 2A minus B doesn't necessarily mean, 2 away from 0 and 1 down from 0. It could really be anywhere on the plane. We don't really know what these vectors A and B are. All right, so let's try to draw this out. So um, I am going to pretend like they are I, J, and K vectors though, just for the sake of answering this question. There are some circumstances where that matters though, so keep that in mind. Okay, so we have the vector P. I'm just going to say that's 1, 2, minus 1. Yep. So that's P. Okay. And then we have vector 3a plus b. So that's probably going to be somewhere like here. So that's going to be q. And we have r. That's something like, so a and then 4b. So here. Okay, cool. And point S is on OP. So O is there. Such as that OS is parallel to OP. Okay, cool. So that makes sense. So it tells us, same direction. So OS is parallel to OP. Cool. And also that RS is equal to R, or is parallel to RQ. Okay, so part A wants us to express OS in terms of K, A, and B. Okay, well, I think this one's pretty straightforward. We just have to plug everything in to that parallel equation they gave us here, this relationship here. So OS is going to be equal to K times OP is 2a minus b, right? So 2a minus b. Cool, easy. That's probably 1 mark there. Okay, this is probably 2 marks as well, part B, and this is probably 1 mark. Now we want to find it in terms of A, B, and M. So I think step 1 is to figure out what R and Q is. Oh, it's also important to note that RS, this term here, is not going to be the same as OS. So we need to figure out a consistent way to go back from RS to OS. Okay, so first things first, let's try to figure out what RS would be equal to. I'm going to pull out a different color. So we have OS, OR. So OR actually, here's a neat trick with vectors. If we know that our final thing is going to be RS, the very first letter should be R. So we're going to go R, O, plus O, S. And when these middle terms are the same, they can sort of cancel out. And so what we're left with is R, S. So that's just a neat vector addition trick to know that you're going in the right direction. The middle terms need to be the same. If you're going in the right direction to add two things together properly, they're going those two middle terms are going to be the same. All right, so we have RS. That's what it's going to be. We can calculate RQ relatively easily as well. RQ is just going to be, again, RO and then OQ. So RO plus OQ. And that's going to give me RQ. Yep. Okay. And the last thing to do is to do RO. We can sort of do a bit of simultaneous equations here. Because we know if I multiply this whole thing by M, these two are now equal, right? So equation 1 and equation 2 are now equal just by simultaneous equations. And so now I can do RO plus OS is equal to M RO plus OQ. Okay. Okay, and then from here we can solve. I'm a little bit lazy. I don't know if I want to keep writing all this out, um, but hopefully you guys get how we're going to go about this. Because we want to figure out OS, right? So one thing we can do is we can subtract RO to the other side. So we have OS is equal to, I'm just going to expand, put the M in both terms. So let's say we have MRO and MOQ, right? We'll have MRO minus RO, so that's going to be M minus 1 RO plus OQ M. Sorry, that's really messy. And then the last thing to do is to chuck in our vectors into here, and then expand and simplify. And that's all that's really left to do. One thing to mention is that RO is equal to negative OR. Hopefully that makes sense. Sorry I didn't go through and work it all out, but I just did everything in algebra and vector notation. Just because I can't, it's probably going to take me quite a while, and you guys will just be sitting here staring at the screen, probably really bored, as I randomly plug in numbers into here. Hopefully that made sense. If it didn't, feel free to throw a question up on Slido, or even after the lecture, feel free to email me about any of these. One thing I should remind you guys is that all of this is up online, like underneath the slide resource, and the lecture is recorded and the slides are also underneath, like in a link though. All right, I'll give you guys a minute or so to have a go at this one here. So use your result from the previous one, and try work it out. Try use the fact that we sort of know what OS is in terms of both. Okay, let's have a go at this. Hopefully that was enough time for you guys to have a solid attempt. Maybe even get an answer. So what I'm going to do is I'm going to use the same result from here, and I'm going to sort of try figure it out from there. I guess I do have to work this out to get an answer. Um, so we'll see how that goes. Hopefully I don't make that many mistakes. All right, so the first thing I'm going to start with is I'm going to equate the result I got here and equate this result here. So I'm going to put them together, and then from there I'm going to try work out what k and m are going to be. All right, so we'll have k 2a. Also, I'm not going to bother throwing in the tildes. or the arrows. Again, I'm sorry. Um, but please do this when you guys do your working out. Make sure you draw in those arrows. And then we'll have m minus 1 r naught r o plus m o q. Okay, so express OS. And so they want us to find K and M. Actually, there's just like that's probably not the way to go about it. Actually, just trying to think. Because I realized if we do this, we are not going to get to an end result that we want. Um, hmm. All right, so I've obviously made a mistake somewhere. Or maybe I haven't. I'm just really brain dead. Uh, find K and M. Okay, so generally when we have two variables, we need at least two equations. So this is probably going to be one of our equations. We just need to figure out what our other equation could be. So RS is probably something like that. RQ is also going to be. This diagram isn't the best, but they're about parallel, I guess. Feel free to throw suggestions in Slido. I'm clearly really like brain dead right now, so no clue what's going on here. Try to figure it out without looking at those suggestions. Okay. OS. We'll look at Slido. All right. Hopefully you guys have thrown up some solutions here. Um, okay. Let's find K and M. Damn, I'm pretty sure I solved this question earlier. That is really a bummer. All right. Hmm. So what I'm looking for here is that I need one more equation so that I can go about solving this. One more equation that is sort of like similar terms here. I mean, I guess I could try work out what OS is. That might be a way to go about it. Maybe the answer is a bit more obvious if I expand this. So we'll have a go at that. We'll actually try represent OS in terms of M. So here, I would get, so OS is going to be equal to, what is RO? So that's going to be negative AM minus 4MB plus OQ, which is 3MA plus MB minus minus RO is just going to be OR. So minus RO, which is plus A plus 4B. If I simplify that, I should get 2MA, 2M plus 1. Oh, yeah, no, I just realized. Um, this is my bad. So I should get 2MA, 2M plus 1A. The reason I'm getting 2M plus 1 is what I'm doing is I'm collecting this term here and this term here, and then I'm adding the 1 from here. Sorry, I am skipping steps. Generally, this is really bad practice to skip steps. And this one here is going to be 4 minus 3M B. Okay, that's what OS is equal to. Yeah, the solution became pretty clear, I think, once I just drew everything out. So um, that's just probably really deserved of me being lazy. All right, so A plus 4 minus 3M B. Maybe you guys have come across this before, equating variables. So I have 2AK here minus BK. So one thing you can do is you can look at all the terms in front of A or related to A and all the terms related to B, and you can say they're the same, right? So for example, if I have 4x plus 1 is equal to AX plus C, we can sort of infer that, A is equal to 4 here and C is equal to 1. Right, so that's basically what I'm going to do with this, just considering the A's and the B's. So looking at all the terms in front of A, I could sort of guess that 2k is equal to 2m plus 1. So 2k equals 2m plus 1, and minus k is equal to 4 minus 3m. And then from here, I can sort of simplify and solve. So I'm going to resolve for k here. So k is going to be equal to 3m minus 4. And then I can substitute this equation back into our original equation. So then it's going to be 3m minus 4, all this times by 2 is equal to 2m plus 1. That's an m though. So this is going to be 6m minus 8 is equal to 2m plus 1. And if I simplify this, is going to be 6 minus 2, so that's 4m is equal to 9, and m is apparently equal to 9 over 4. I don't know if that's right. There's a chance it's not. It's actually a very high chance it's not. Because maybe I made a mistake with my algebraic manipulation here. Because that was all pretty rushed. And then k apparently is 9 times 3, which is going to be like 20. Oh, mind blank again. So 9 times 2 is 18. What I'm going to do here, so generally whenever I have mind blanks like this, which happens a lot in exams, I split everything up into tiny bits. So we'll get 18 plus 9. Just to make sure I'm not making a simple mistake with this addition stuff here, I'm going to do plus 2 to this, so that's 20, 27. So apparently it's 27 over 4 plus, I'm going to convert this to, minus, sorry. I'm going to convert that to 16, minus 16 over 4, which is probably 15 over 4. Alright, sorry about that. I have no clue what happened. I think I just blanked. on all of this. So there is, hopefully this is correct. Maybe it looks sort of correct from memory, but there's a high chance it's wrong just because I rushed this step. So, um, so one thing you guys probably saw me do at the end was this one, which is a bit weird. And the only reason I did this is because like in high school, I used to make a lot of silly mistakes. If you come to the other lectures that I've done, you've probably heard me say this so many times. Like silly mistakes were like the bane of my existence. And so, it was simple things like doing 9 times 3 is like 24, right? Which is obviously not true, but yeah. Um, and simple addition mistakes like this that could have happened here. I'm not sure. I'm not gonna really go back and double check, but to prevent myself from making these mistakes, I do like really, really clear steps, which isn't shown here. But if I was doing this on pen and paper, I'd have one line per set of working out. I'd show like everything. I'd show, instead of converting this to 16 over 4 straight away, I'd do 4 times 4 over 4. And then in the next step, I'd do 27 minus 16 over 4, and then maybe 27 minus 10, and then 27, 17 minus 6. I realize that's wrong as well, now that I'm talking about it. Cool. But yeah, you can probably see how easily I make silly mistakes. And I feel like the easiest way to crack down on silly mistakes is just showing every single step. So what I should have done was 27 minus 10 minus 6. So that's going to be 17 minus 6, which is going to be 11. Yeah, that should have been blaringly obvious, but that's the thing with silly mistakes. They're not until you double check them. All right, hopefully that makes sense. I'm sorry for all of that there. I just made, yeah, too many silly mistakes. I think there was a question on how to avoid silly mistakes. This is one of those ways. Writing out every single step of working out, double checking yourself as you go through every single step. And one thing I like to do is like sort of talk to myself during my exam. Every time I do a step, I'd rerun that step in my head, just so I'm sort of like double checking everything as I'm going along. All right, so hopefully this question made sense. And yeah.